Welcome to this lesson video. In this lesson video, we are looking at how to convert a recurrent decimal to a fraction. Now let us get to it. Now suppose we have this example. Now we all know that this notation simply represents that 3 is a recurring number. Sometimes it's written like this, so it means in this case 3 is the recurring number. Now in this case we know that this is the same as 333. Now what is the first step? The first step, we let x to be 0,333. Now the second step that we need to do, we need to shift this comma from here to the first number which is recurring. In this case, you know that 3 is the number which is recurring. Now that is what we are going to do. Now before we shift this comma, take note that when we shift a comma with only one step, we multiply by 10. 2 steps, we multiply by 100. 3 steps, we multiply by 1000. Simply write this down and then I'll explain. Now going back to our question, this comma, we can see that it will shift only one step, so it means we're going to multiply this equation by 10. Now what is x multiplied by 10? It's 10x. Now basically what is happening, for us to shift this comma from here to the first number which is recurring, we are actually multiplying by 10. So this number multiplied by 10, it will give us 3,333 recurring. Is the same as shifting it one step. Now from here, what do? We simply label our equations. Now this will be equation 1, this will be equation 2. And then from there, what do? We are going to subtract equation 2 from equation 1. Actually, we are going to subtract equation 1 from equation 2. Now, what is 10 minus? We all know that if you don't see any coefficient, next to a variable, we know that we have 1. Now, 10 minus 1 is 9x. And then before the comma, 3 minus 0, it's simply 3. Now after the comma, we have 33333 minus 33333, and then our answer will be 0. Now from here, we simply solve for x. Now we divide both sides by 9. Now what happens is that this will result into 1. 1 multiplied by x is x. Now 3 over 9, that is our final answer. But then we see that this is not simplified. Is there any number which is divisible into 3 and 9? Yes. 3 goes once into 3, and then 3 goes 3 times into 9. This is our final answer. Now let us look at our next example. (0,17) recurring. Now how do we do this sum? Now feel free to pause the video and work out this question. When you are done, you can play the video and verify your answer. Now we can see that we have a different sum compared to the previous one. Now how do we work out this one? Now we need to take it step by step. Now the first step, as usual, we let this to be x 7 7 7 7, and you must be very careful with this one. 7 is the only number which is recurring, so it's not 1 7 which is recurring, but it's 7 only. Now in this case you can see that the number just after the comma, it's not a recurring number. So the actual number, the actual first number which is recurring, it's 7 in this case. Remember I said we shift this comma to the first number which is recurring, but from here we cannot go straight to the first number which is recurring. We must take it step by step. So we'll start by shifting this comma to the number just after the comma, and then from there, from the number just after the comma, we go straight to the first number which is recurring. I hope it makes sense. Now let us perform our mathematical operations. Now remember, one step it's multiplied by 10, 2 steps it's multiplied by 100, 3 step is multiplied by 1000. Now since we are going to shift only one step, we are multiplying by 10, so 10 multiplied by x, it's 10x, it's equals to, then this number multiplied by 10, it will give us 1,7777 recurring. I hope you can see that. Now what is our next step? Our next step, we go back to our original equation. Now from the original equation we are going to shift this comma 2 steps from the original position of this comma. So we go straight to the first number that is recurring. Remember, 2 steps it's 100, so 100 multiplied by x, it's 100x is equals to, and then we are going to have 17,777 recurring. Now you can see that we have 3 different types of equations. Now which one do we label and which one do we use? Now we can say this is equation 1, equation 2, equation 3. Now in this case we are no longer considering equation 1. We are going to focus on equation 2 and equation 3. Why? Now if you can check equation 1 and equation 2, let us look at the numbers after the comma. If the numbers after the comma are not the same, we cannot use these equations. Now you can see the first equation, which is equation 1, we have 0,17777. Equation 2, we have 1,77777. The number just after the comma is 1 on equation 1. The number just after the comma is 7 on equation 1. It's very important that our numbers after a comma must be the same in order for us to subtract and find the difference of 2 equations. So our next step, we are going to focus mainly on 2 and 3 equation. So we are going to subtract equation 3 and 2. Now let us look before the comma. 100 minus 10 is 90. It's equals to, before the comma, 17 minus 1 is 16. After the comma we have 7777 minus 7777. Our answer will be 0. From here we divide by 90 both sides. Remember, we are solving for x. Now this will result into 1 multiplied by x, it's x, and then we have 16 over 90. Now simplifying this further, 16 over 90, it's 8 over 45. This is our final answer. Now you can also prove this. You punch this on a calculator and then you will get this recurring decimal. Let us look at the next example. It's similar to the previous one. So simply pause the video, work out the question, find your answer, play the video and verify your answer. Now let us get to it. We let x to be 1,1555. Now you can see that the first number just after the comma, it's not a recurring number. So we do it like the previous question. We multiply by 10. Recurring. From there we go to our original equation. We multiply by 100. Then from here, it's equation 3 minus equation 2. (100 minus 10) it's 90. Before the comma we have 115 minus 11. The answer is 104. After the comma we have 55555 minus 5555. The answer is 0. Now from here we solve for x. We divide both sides by 90. This will cancel this. Actually 90 over 90 is equals to 1. 1 multiplied by x is x. 104 divided by 90, we have 52 over 45. So this is our final answer. I hope you got it correct. Now we move to the second one. Actually the next one. So our next question is a bit different from the previous ones, but then we know the procedure. Now we let x to be 2,1454545. So we can see that the number which is recurring is 45. Okay, so as usual we are going to take it step by step. So we are going to shift this comma to the first number which is not recurring but after the comma. So we have 21, 454545. Now don't forget that we multiply by 10, so we have 10x. Now going back to the original one, we take it straight to the first number which is recurring, which is here. So you can see that it's how many steps? It's 1, 2, 3. So we multiply by 1000, and then we have 2145, 45 45 45. This is equation 1, 2, and 3. (1000 minus 10) it's 990. 2145 minus 21, it's 2124. So you can see that 454545 minus 454545, it's 0. Now we divide both sides by 990. This will result into 1. 1 multiplied by x, it's x. Now 2124 divided by 990, it's 118 over 55. This is our final answer. I hope you got this one correct. Now this is the end of our lesson video. I hope you now can perform this operational mathematical steps in order to convert from decimal to fraction form. This is Bahula SJ. Thank you very much.